In my earlier video, I had discussed about basis of a vector space and dimension of a vector space. I had seen basis with a bunch of vectors which generate the whole space, and these vectors are obviously linearly independent. And today our discussion about basis and dimension of not whole vector space be a subspace. The actual goal of this lecture is consider M cross N matrices and find column space, null space and row space of these matrices. These three spaces actually subspace of these matrices. Now I will find the basis and dimension of this subspace. And to find basis of dimension of these three subspace is very important for any competitive exam. Not only CSR NET, GATE, TIFR, NBSM, for all competitive exam, to find the basis and dimension of three subspace is very important. The idea is, consider R3. We all of us know the standard basis of R3 are 1, 0, 0, 0, 1, 0, 0, 0, 1. Now consider another basis of R3. Consider 1, 1, 2, 2, 2, 5 and 3, 3, 7. And notice these vectors be the linear combination of these two vectors. So these two vectors obviously linearly independent, but these vectors not linearly independent. So these three vectors not the basis of R3. But since these two vectors are linearly independent, then these two vectors span this plane in R3. And this vector be the, consider 1, 1, 2 and this be the 2, 2, 5 and 3, 3, 7 be the linear combination of these two vectors. So these two vectors generate this plane. These two vectors 1, 1, 2 and 2, 2, 5 are linearly independent and span this plane. That means these two vectors are basis of this subspace. Here the subspace is the plane in R3. So this is obviously be subspace of R3. Then these two vectors 1, 1, 2 and 2, 2, 5 are linearly independent and span this plane. That means these two vectors are basis of this subspace. Here the subspace is the plane in R3. So the definition of basis of a subspace is a bunch of vectors A1, A2, An is a basis of a subspace S of the original vector space V. This is basis when this bunch of vectors A1, A2, A3 up to An span the subspace and these bunch of vectors are linearly independent set. Okay, this is the actual definition of a basis of a subspace. And algebraically this means these three vectors generates a matrix which has a solution Ax equal to B. Here B be the linear combination of these three vectors. Now I will define some rules to find basis of a column space of a vector space. The rule says the column of a matrix A are linearly independent if the system Ax equal to 0, only trivial solution. That means when in each column there exists no free variable, then the vectors are linearly independent. Second, the column of the matrix M cross N span Rm if and only if A has a pivot in each row. That means when the matrix has a pivot in each row, then column of the matrix are span Rm. See, find a basis of a subspace of R3 who is spanned by following vectors 1 1 minus 2 minus 10 minus 8 20 minus 24 minus 18 51 minus 42 minus 32 87, and these column vectors generate the matrix A. That means here the column space of A spanned by these 4 vector. Now we have to find the basis of this column space of A. Now after row reducing from, these would be reduces 1 0 0 minus 10 2 0 minus 24 6 3 minus 42 10 3, and notice these 3 columns are pivots. Since these 3 columns are pivot, so this consists in original column. That means these 3 columns are basis of this column space of A. Means basis of column space of A are 1 1 minus 2, since this is consist original matrix, minus 10 minus 8 minus 20 and minus 24 minus 18 51. These 3 are basis of column space of A, and dimension of column space of A is 3. That means, and since here dimension of column space is 3, and since the column space is all linear combination of column, that means this is actually whole R3. This vector actually generate whole R3. Are you getting? Now I will see another type of subspace, null space of a M cross N matrix. Null space of a matrix A imply the set of all solution of Ax equal to 0. That means all solution map to 0. And if A is M cross N matrix, then null space of A always be subspace of Rn. And this is subspace of Rn because there is n variable in the equation Ax equal to 0. Are you getting? Well. And if we want to find null space of this matrix, then we have to row reduce again. Then after row reducing, I will get this matrix. Here we have to find the solution of Ax equal to 0. This column be free variable. Therefore, this is x1, this is x2, x3 and x4. Therefore, we can write easily x1 plus 2x4 equal to 0, x2 plus 2x4 equal to 0 and x3 plus x4 equal to 0. Therefore, the basis of null space is, consider this is x1, x2, x3, x4. That imply x1 equal to minus 2x4, x2 equal to minus 2x4 and x3 equal to minus x4. Therefore, put the value. Then this would be minus 2x4, minus 2x4, minus x4, x4. And therefore, the null space actually generated by this vector x4 times minus 2, minus 2, minus 1, 1. This actually represent all solution of Ax equal to 0 vector. So, this is actually null space which actually spanned by this vector minus 2, minus 2, minus 1, 1. And this is the basis of null space. Therefore, null space of any matrix is determined by free variable of the matrix. Are you getting? Well, now I will define new type of subspace, row space. Consider A be M cross N rectangular matrix. A set of vectors that span row of the matrix is called row space of the matrix. Space of A is subset of Rn. Okay? If you want to find row space of this matrix, then row space would be all combination of the row, and if you want to find all bases of row space, this would be such vector which generate all row and which are linearly independent. That means these would be are linearly independent vectors in row equivalent form. Also, this 3 row generates whole matrix. So, basis of row space of A would be set of those vectors which contain 1 0 0 2 0 1 0 2 0 0 1 1. And notice this is actually subspace of R4. Are you getting what is the row space of a matrix? I have told you in M cross N matrices, row space always would be subspace of Rn. Here I have considered A is 3 cross 4 matrices. So here the row space is subspace of R4. That means in any M cross N matrices, there exists 4 subspace, 1 column space of A. This is actually subspace of Rn because column space of A set of all B in Rm such that Ax equal to B. Actually, this is the set of all vectors that span all column. Second, the row space of A. Row space of A be the all combination of rows, and row space be the subspace of Rn. And row space of A similar to all combination of column space of A transpose. That means row space of A similar to column space of A transpose. And null space of A means set up those vector in Rn such that Ax equal to 0. This is subspace of Rn, and fourth subspace is null space of A transpose. Since the null space of A be the subspace of Rn, so null space of A transpose would be subspace of Rn. In this subspace, there exists different type of bases. Are you getting the idea? This is very nice type of subspace, and this type of subspace are more important for any competitive exam. Well, and dimension of column space of A is defined as column rank of the matrix A, and dimension of row space of A is defined as row rank of the matrix A. And actually fact is column rank always equal to row rank, and which is equal to rank of the matrix. That means rank of the matrix is actually column rank and row rank is equal when. Actually this is always equal. Notice in before example, here dimension of column space is 3. Dimension of row space is also 3 because these contain 3 vector. So obviously dimension of column space and row space always be equal. Now I will introduce one easy method to find basis of any space. Consider the space Rn and construct a matrix A where R1, R2, Rn be the row vector and C1, C2, Cn be the column vector, and consider determinant of A not equal to 0. Then collection of row vector means R1, R2 up to Rn, which is actually similar to transpose of all column vector be the basis of Rn. Now I will define some nice subspace. Consider the vector space R3 with the field R. Then the subspace U equal to set of those x1, x2, x3 belongs to R3 such that 2x1 plus x2 equal to 0 and x1 minus 3x2 plus x3 equal to 0. This is obviously the subspace of R3. This is actually the homogeneous system of equation. Here number of unknown is n and number of equation is m. Here the number of unknown is 3 and number of equation is 2. So these two equation reduces this matrix whose column vector would be 2, 1, 1 minus 3, 0, 1. And the solution would be such type Ax equal to 0. Here these three vector be the unknown vector. Row reduction, finally if this is the A matrix, this would be reduces this term and here this will be the pivot. So rank of this matrix A is 2 and number of free variable here 1. Means rank of the matrix is 2. So dimension of row space equal to always dimension of column space. Here dimension of column space would be generated by 2 vector. Of row space would be generated by these 2 vector. The question has introduced find the solution of this equation. That means we have to find null space. Obviously by row reduction you can to find the basis of null space. Another easy method is if you want to find basis of these two equation, then from this line we can write x2 equal to minus 2x1 and put the value here. Then this would be x3 equal to minus 7x1. Then the vector is such type x1 minus 2x1 minus 7x1. Therefore U is generated by x1 times 1 minus 2 7 where x1 belongs to real number. Means the basis of this set U would be 1 minus 2 7. Since this set U contain only one vector, that means dimension of this set is 1. Are you getting how we have to find solution of any homogeneous equation? Well, next example is set of all x, y, z belongs to R3 such that x minus y plus 2z equal to 0. Solution of this equation. This is actually similar to before homogeneous equation. To find the basis and dimension of this subspace, we can solve this by Gauss elimination method similar to before. Another easy method to find the basis of dimension of this subspace is, at first see the dimension. Here to find the dimension the rule says number of parameter minus number of unknown. Here the number of parameter is 3 and number of unknown equation is 1. That means this is equal to 2. And to find basis, consider z equal to alpha and y equal to beta. That imply x equal to alpha minus 2 beta. Therefore, put the value, this would be alpha minus 2 beta, beta alpha. And this is equal to alpha times 101 plus beta times minus 2 101. That means the subspace is spanned by two vector 101 and minus 2 10. Therefore, basis of this subspace would be generated by these two vector 101 minus 2 10. Are you getting? This is just easy method to find the basis of this subspace. Are you getting? We will see new type of subspace. P belongs to P2 such that P prime 0 equal to 0. Here the vector space is P2R. And subspace is such polynomial such that P dash 0 equal to 0. Let's consider an arbitrary polynomial of degree 2. Then P prime x equal to 2x a0 plus a1. And here the restriction is in the subspace P prime 0 equal to 0. That implies a1 equal to 0. And since a1 equal to 0, that means this subspace contain a0 x square plus a2, where a0 a2 belongs to real number. And this is actually the set containing 1 x square. Obviously this set is linearly independent and this set span this subspace. So this is set containing 1 x square be the basis of this subspace. Are you getting? How we have to find basis of any subspace? Okay, I will stop here. In my next video, I will discuss linear transformation. But at first, I will highly recommend you. Please see today's video with pay attention. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel. Thank you so much.